Okay, so let's go over how we would answer question 1A, B, and question 2 for activity 2.2, feeding a crowd. So there's a couple of different ways that we can approach this. As was pointed out in the notice and wonder earlier in this slideshow, when you work down the table, it is called scale factor. So we can continue to use scale factor to figure out how many cups of rice, or how many people will 10 cups of rice serve. So if I do that, if I work down, I'm going to ask myself, what times 2 is equal to 10? Well, we all know 2 times 5 is equal to 10. So I'm going to use that same number on the other side of the table and work my way down. So I'm going to go 6 times 5. Well, we all know 6 times 5 is equal to 30. So I know that 10 cups of rice will serve 30 people. Now, there's also another way to look at this. Okay, let's switch colors. Instead of working down the table, we can also work across the table. So notice if I go 2 to 6, I can multiply by 3 to get that number, right? 2 times 3 is equal to 6. Well, then I can then apply that to 10 as well and also multiply by 3. So 10 times 3 is equal to 30. So there you have two different ways to address the same question. Now let's take a look at question B, which states how many cups of rice are needed to serve 45 people. So again, we have a couple options, but let's go ahead and stick with moving across the table. So we know if we were to move in the other direction, so for example, from 9 to 3, that would be the same as saying 9 divided by 3 is equal to 3, right? But we really want to focus on the multiplication form of this. So instead of saying 9 divided by 3, let's change this to a multiplication problem. So if you recall, we can rewrite this as a multiplication problem by multiplying by the reciprocal of this number right here. So the reciprocal of 3 is 1/3. So 9 times 1/3 is also 3. Well, I'm going to apply that to the 45. I'm going to multiply by 1/3. So 45 times 1/3, you can treat it like this, put a 1 over the 40 under the 45. 45 times 1 is 45. 1 times 3 is 3. And then I'm going to divide. 45 divided by 3 is 15. So we would say that 45 people would need 15 cups of rice. All right, let's take a look at question 2. So we're going to apply those same strategies that we use for the previous question to answer this question. And again, you can work down the table, you can work across the table, or even you found a different strategy that works for you as well. But let's finish filling out the table. So one thing you may have observed is that I can turn 6 into 3 by multiplying by 1/2. Okay, so if I do the same thing to 30, 30 times 1/2 is 15. I can do the same thing to 40. 40 times 1/2 is 20. Now for the last one, I would have to think of it going in the other direction. So how does 3 turn into 6? Well, you can multiply by 2. So I'm going to apply that to the 28, and 28 times 2 is 56. So my answers are going to be 15, 20, and 56. That's what I would fill out. Now, some important things that I want to point out in this activity is if we were to make ratios of these numbers. Now, keep in mind when we make the ratios, we're always going to put the second column on top and then the first column on bottom. So anytime you write a ratio, it's always second column over the first column. Okay, that is a given. So if I were to write this ratio, I would get 3/6. Now I can simplify 3/6 by dividing by 3 over 3 to get 1/2. Let's do it for the other 3 as well. So I have 15 over 30. I could simplify this by dividing by 15 over 15 to get 1/2. Okay, 20 over 40. Again, I can divide by 20 over 20 to get 1/2. And then finally, 28 over 56. This one, I could divide by 28 over 28 to get 1/2. Now, maybe when you simplified, you took a couple more steps and didn't use the same numbers as me. That's fine. You should have ended up with 1/2, though, for every single one. So one thing I want to point out is that we talked about in the previous unit how these equivalent ratios are really important to scale factor or in scaled copies. The same idea is important for proportional relationships. So equivalent ratios make a proportional relationship. Now, proportional relationship was one of those new vocab words that we were talking about. So this is a really, really, really important key takeaway. If you have ratios that are equivalent, not only are they scaled copies like we talked about before, but they also make a proportional relationship. So keep that in mind whenever we have a situation like this where two quantities are always in the same ratio, we say there is a proportional relationship between the quantities. So the statement that I could make about this relationship would be the number of spring rolls is proportional to the number of people. Again, this is a really, really important concept. So what I'm going to ask that you do is pause the video at this time and take a quick screenshot. Add this to a notability document and label the document Unit 2, Lesson 2.